I myself, Dr. Mahanti, welcome you for this session. Now, today my topic is the comparative study of group 17 element. First, elements present in group 17. The elements number 1, elements present. Elements present. Fluorine, chlorine, bromine, iodine, astatine. These elements, its atomic number is 9, 17, 35, 53, 85. Fluorine, chlorine, bromine, iodine, astatine. Nine, 8, 17, 35, 17, 53, all right, 53, it is 82, 85. Now, its electron configuration is electron configuration of fluorine 1s2, 2s2, 2p5. Chlorine 1s2, 2s2, 2p6, 3s2, 3p5. You may write this also, this is neon 3s2, 3p5. Similarly, here we may write 4s2 outer level 4p5. Here is 5s2 5p5. Here we may write 6s2 6p5. So all the elements of this group contain 7 electrons in the outermost shell. It contains 7 electrons in the outermost shell. And this last electron, as the last electron goes to p orbital, last electron goes to as last electron goes to p orbital, and these group elements are called, these group elements are called p block element. So p block, s block, p block, d block. So group 17 is called p block elements. Its position in the period table we may write like this. Position in the period table in the periodic table. First, the group 17, it is group 17. In this side, group 16, it is group 18. So, in the fluorine, in the left side, it is 9, here is oxygen, 8. It remains between, these elements remain between group 16 and group 18. Oxygen, sulfur, selenium, tellurium, polonium. In this side, helium, neon. Helium will remain first, we are write down helium, beginning day. Then neon, argon, krypton, xenon, radon. Now, you find here is FCl, bromide, iodine, At. So these elements will remain between group 16 and group 18, that is oxygen group element. and inert gas element, a zero group element. It is called inert gas. Inert gas elements. Inert gas. Here its configuration is, it is a p block. Here the p block, it contain 2s2 outermost 2s2 to p4. It contain 2s2 outermost at 2s2 to p5. It contain 2s2 to p6. Like this. This is the position in the periodic table. Then we'll go, we have to complete study, we'll discuss the complete study of that, of group 17. I will discuss first size. Size. Number A, size. Now fluorine, chlorine, bromine, iodine, astatine, the size increases because it is beta cell 2s2 to p6. Here 3 left 3, here is 4, 5, 6. Since it contains number of cells increases, number of cells increases, cells increases. The cell ta body was size, cell bolle, you look at here, it is 1, 5, and 1, and is 2. Jette cell body or number of cell increases, the size increases. The size, number of cells increases, the size increases, the size of these elements, increases from top to bottom. We will discuss of iodine because astatine is a radical element, but fluorine, chlorine, bromine, iodine, the most we will discuss these points. So iodine is bigger size and fluorine is the less size. It is 2s2 to p6, you may write this 2s2 to 3s2 to 3p6, 4s2 to 4p6, 5s2 to 5p6, like this, 6s2 to 6p6. Then jette upur tolku jiba, size ta body jiba. Kain size body jiba? Because number of cells increases. Then we will goes to ionization enthalpy. Second, discuss size. Number B, ionization enthalpy. Ionization enthalpy. What is ionization enthalpy? The energy required to pull out, the energy required to pull out the outermost electron from the isolated gaseous atom is called ionization enthalpy. It's called ionization enthalpy. Aguru to janite periodic classification re is called ionization enthalpy. That is jette size body jibo. When A is there atom A, you take one electron, it form A plus E minus electron plus energy. We supply some energy to take out the electron. Gote luhate chumbak ta अछि. Chumbak je pakha rahibо taniya pai besi energy darkar. Dura rahile energy kam darkar. Tale ei case ame dekhiba je bigger size tolu gala beloku, then easily we can take out the electron because force of attraction kami jibo. Nucleus is positive charge, electron is negative charge. So positive negative jo attraction will decreases. Attraction decreases, hence ionization energy will be less. So hence therefore the ionization enthalpy decreases from fluorine to astatine. Ionization enthalpy decreases from top to bottom. that is as the size increases jette size बढ़िबो सेता आउने एनर्जी कमी जिवो एनर्जी इजीली हमें इलेक्ट्रॉन बाहर करि परिबा then we'll go to the electron gain enthalpy C electron gain enthalpy electron gain enthalpy or you may write this or this is called electron affinity electron let us see electron affinity by electron gain enthalpy is like this suppose here is a gaseous atom plus E A minus plus energy so the energy released by gaseous atom to form released by gaseous atom by addition of one electron by addition of electron by gain of electron by addition of electron it's called electron gain enthalpy ताले गोटे इलेक्ट्रिक उल्टा तार इलेक्ट्रॉन गैन एंथैल्पी किंतु एटी ऑर्डर नाही बट इलेक्ट्रॉन गैन एंथैल्पी द मोस्ट इंपोर्टेंट पॉइंट इज इट इज रिलीज्ड chlorine and fluorine bromine iodine first हवा का फ्लोरीन किंतु फ्लोरीन हो नहीं क्लोरीन हाइस्ट देन फ्लोरीन क्लोरीन इलेक्ट्रॉन gain enthalpy is more than fluorine बुझे भी कहीं then decreases fluorine तब bromine iodine like this तल बर्तन why the chlorine question is yours why important why chlorine has high electron gain enthalpy than fluorine electron gain enthalpy than fluorine in this case we can explain by factors are number 1 this can be explained the fluorine has less size 1 point you can explain by this due to less size of fluorine what a point the less size of fluorine over there inter electronic repulsion is more inter electronic repulsion is more in case of fluorine so the internal repulsion of BCl size कम है so difficult to take out one electron जदि गोटे इलेक्ट्रॉन ना पाए difficult है ताले energy will be required release will be more hence the chlorine has high electron gain enthalpy than fluorine answer will be 2 points one is due to less size of fluorine and inter electronic repulsion then we will discuss oxidation state I am writing clearly out there oxidation state which is important oxidation state only one oxidation state fluorine exhibit कहीं कि why exhibit only one oxidation state that is -1 only that is -1 as it is the most or plus 9 जहाँ से मिसले माइनस हम as it is the most electronegative element. It is the most electronegative element. जितने एलिमेंट हम अच्छी सबुठार the most electronegative element is fluorine. Question पचारे which is the most electronegative element? You have to answer that fluorine is the most electronegative element in the periodic table. ये जहाँ से मिसिबो it will exhibit negative. Hence it will be charged -1, whereas others exhibit, कहीं कुछ बुझे देवी, others exhibit with +1, +3, +5, +7, +7 केवल ये -1 ये मतलब -1 छोड़ा है देखो +1, +3, +5, +7. That can be explained by taking the electron configuration. Let us discuss why fluorine exhibit only -1, what is the other exhibit higher oxygen state. Let us say fluorine 9, 1s2, 2s2, 2p5. So 2s2, 2p5. It is fluorine. Similarly, chlorine outermost is 3s2, 3p5, 3s, 3p. So in the bromine 4s, 4p I would like this, 4s, 4p same, 4p, 5s, 5p like this. Now here there is no d orbital because second cell has no d orbital, present. Here presence of d orbital. Chlorine case there are 3d, 2 d nahi, 2 maximum s or p, 3d 1 2 3 4 5 d are 5 orbitals. So if this is the case fluorine, there is no jumping of electron from 2p to higher orbital, hence only one electron remain in a one orbital, that is partial filled. One 2p orbital is partial filled, only one 2p orbital is partial filled, there is no possibility of other states, no possibility of excited state. Excited है परिवन, तेनु it exhibit only one. First it exhibit one. गोटे इलेक्ट्रॉन अच्छी one partial field, जितना partial field जितना को bond करिबो, it exhibit one of the state, and it is one is either +1 or -1. Since fluorine is the most electronegative, F is the most electronegative, hence it exhibit जहाँ सुधा मिसिले exhibit -1. आउ तार किछ नाही, गोटे एलिमेंट जे देखा है -1 आउ तार no change, that is fluorine, which is most important point. What is others? Look at here, others, chlorine. In case of chlorine, there is possibility of excited state. In the excited state, one electron jumps from here. It will give like this. Maybe possible is that. So there is possibility of 3s, 3p, 3d. So 3 orbitals remain partial filled, therefore here the oxidation state is 3, either +3 or -3, depends on nature, +3 or -3 like this, 1 2 3. So this state again to exhibit plus 5 states. And the result is possible, it exhibit that is jump kale, we get possibility there. Plus 7 state, like this. Then only exhibit fluorine only 1, -1, what is others? Chlorine, what is others? Chlorine, bromine, iodine, exhibit 3, 5, 7 plus 3 plus 5 plus 7 plus 3 plus 5 plus 7 states. Beside these states. This is the octane state of halogen elements. Then we'll show some chemical property I will discuss. Hydrides. Formation of hydrides. Formation of hydrides. Hydrides. Fluorine from hydride. The hydride means hydrogen plus halogen element. Hydrogen plus halogen. It halogen group को जाए. Halogen it form hydride. Hydride of halogen. Hydrides of halogens. Halogen hydride. You may write halogen hydride. Halogen then hydride. Halogen hydride. Look at here. Fluorine. It's hydride. Hydrogen miscible. Miscible fluorine forms hydride hela HF. Fluorine hydride HF. Chlorine similarly it form hydride HCl. Bromine form hydride. The hydrogen khali miscible HBr. And iodine forms hydride like HI. These are the formation of hydrides. HF, HCl, HBr, HI. Now, we can explain the acidic character of hydrides. Acidic character. Number A, we can explain the acidic character of hydrides. Acidic character of hydrides. This acidic character, HF the weakest acid. HF the ସବୁଠୁ କମ୍, then comes HCl, then HBr, then HI. HI the strongest acid and HF the weakest acid. Among these, HI is the strongest acid, and HF is the weakest acid. Why? Weakest acid. That can be explained. Number one, the bond energy of HI, the bond energy, bond strength, bond energy, the bond strength weak. Bond strength is weak. HI, then HF, then HF bond strength BC, then HF. A bond strength is weak. And our size of iodine is greater than fluorine. So the bond ta weaker achi, then easily bhangi jibo. Bhangile it will give easily. HI gives H plus I minus. So bond ta easily bhangi hola, H plus I minus dei dela, then the substance which is capable to give proton is called acid. Jahar jete capacity besi thibo, sete acid. যেহেতু HI র বন্ড স্ট্রেংথ বহুত কম and size bigger, automatically bond ta bhangi jala, bhangi automatically gives H plus I minus quickly. Therefore the acidic character of hydrides HF, HCl, HBr, HI. HI is the strongest acid because weak bond strength of HI. acidic character. Then I will tell you stability. Stability. जब जे भांगी जाउची रही पाउनी इमिडिएट भांगी जाउची ताले अनस्टेबल जे स्टेबल हो ताले उल्टा HF is more stable, HF is more stable than HCl. Similarly we can explain HBr and HI. Stable means it remains as such. ये हाइड्रोजन दे पाउनी क्योंकि हाइड्रोजन दे दला इमिडिएट भांगी जाउची जब इमिडिएट भांगी वाला become unstable. HI remain unstable and HF is the most stable. Most stable. Then another question is why HF is a liquid, stable what बुझे परिया, HF is a liquid, HCl is a gas. Why hydrogen fluoride is a liquid, hydrogen chloride is a gas. That can be explained stability by stability because HF is more stable than HCl. The fluorine forms hydrogen bond. Fluorine forms. This is called hydrogen bond. Since fluorine forms hydrogen bond strength increases between this, it becomes stronger. Hence, due to hydrogen bond, HF is a liquid and HCl is gas. Go to one point. Why HF is a liquid? That is only due to this is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Hydrogen bonding jogu HF is liquid. The reducing character. Total acidic character bijayli, then stability, reducing character. The reducing character is the equal to HF has सबुठ कम HF, then come HCl, then HBr, and HI. Jim the acidic character, it was say what happened. The reducing, and easily reducing huge, HR bhangi huge, it gives proton immediately bhangi the badara, reducing character, HF is the least reducing character, and HI is the most reducing character. This is all about hydrides of this. Then oxidizing power. This is the hydrides. But the molecules remain in diatomic state. The molecules, fluorine, it remain F diatomic state. Remain as all remain as diatomic states. Diatomic state. Fluorine remain as F remain as F2. Cl remain as Cl2. Molecular state. Br remain as Br2. I remain as I2. Remain as diatomic state. Molecular form. Molecular form. All the atoms, two atoms combined form fluorine, chlorine, bromine, iodine. Among these, fluorine, chlorine, bromine, iodine, the stability increases. These are gases. The liquid. This is solid. So stability of fluorine, chlorine, bromine gradually increases. That is due to increase of size. Due to the size body was the stability of the body, increase of size. Its oxidizing power. Why? Fluorine is more oxidizing power than iodine. The oxidizing power, the oxidizing power, fluorine is greater than chlorine, then bromine, and iodine. Why? It is a question kari parapile. देखो क्लोरीन रोचे इलेक्ट्रॉन एफिनिटी बेसिक we know the electron gain enthalpy of chlorine atom. Chlorine is greater than fluorine. Chlorine is greater than fluorine. किंतु ऑक्सीजन पावर कहीं फ्लो why oxidizing power of fluorine is greater than chlorine. Ulta check. So this can be explained by three factors. Number one, first depend on 2 points. Number one, depend on three factors. First, X2 gas, half X2 gas. Dissociate color will get Xg. This energy is called del H dissociation energy. Depend on dissociation. It is positive. Its value is positive. Half X2 Xg, it is a dissociation energy. Half del Hd, I am right, half del Hd. Then B, second point, Xg plus E minus, it formed X minus G. Here is electron affinity, Ea. By electron gain enthalpy, this is called Ea. Then we will get X minus C. It is always negative. It is negative. X minus gas plus aqueous, it form X minus aqueous. It is the hydration. It is called heat of hydration. Del H is negative. It is hydration. Del H hydration. Hydration, which is negative. So this value, oxidizing power of fluorine can depend on experiments with any halogen element, depend on three factors. What? Dissociation. Only not depend on electron gain enthalpy. It depends three factors: dissociation, electron gain enthalpy, and hydration. In three factors it depends, and it was calculated. The value was found. The del H of chlorine is total value chlorine. Oxidizing power is summation of this, we find F2G form F minus aqueous. The energy value was calculated minus 753.5 kJ. And chlorine we find Cl2G with Cl minus aqueous, we get value is minus 708 kilojoule. So this value 753, here is 708. So the oxidizing power from this value we can find that fluorine is more oxidizing power than chlorine. It only does not depend on electron gain enthalpy. It depends on three factors: dissociation, electron affinity, and hydration. তাহলে আমি বুঝলাম অক্সিজেন পাওয়ার অফ ফ্লোরিন, ক্লোরিন, ব্রোমিন এন্ড আয়োডিন। Some oxides, formation of oxides. Formation of oxides. Fluorine only form oxide F2O. OF2, am I right? OF2. And oxygen of positive part, OF2. Fluorine forms OF2. Whereas chlorine mother form करे Cl2O, bromine mother Br2O. Here the oxidation state is of this is 1. Chlorine form fluorine, chlorine forming like this, monoxide. It is monoxide. It forms like monoxides. Fluorine from this, chlorine forms this, bromine from this. Chlorine, bromine. Chlorine मध्य अब अलग करिया हम परे ClO2, Bro2. Again, it forms Cl2O3, Br2O3. Another Cl2O7, like this. So oxides, in this case, the oxidation state is +1 or -1. It is always -1, it may be +1. So this is will be +4, oxidation state +4. Here is Cl2O3 6 plus 3. Here is exhibit plus 7 like this. Give different oxidation oxides, give different oxidation states. Then oxyacids. Oxyacids. HCl is chlorine forms oxyacids, chlorine form mainly oxyacids, HCOCl, HClO2, HClO3, HClO4. It is called hypochlorous acid, hypohalous general acid HOX you may write, or hypochlorous chlorous, hypochlorous acid, chlorous acid, chloric acid, and this is perchloric acid, perchloric acid. So among these oxyacids, all bromide, similar bromide form like this, HOBr and HOI like this, bromide also forms HOBr, HBrO2, HBrO3, HBrO4 like this. A chloride and bromose, how some saman. Hypochlorous, hypobromose, bromose, bromic acid. So the acidic character of this, jete oxygen badhutubo, sete acid badhibo. The acidic character of HOCl is least, then HCl, O2, then HClO3, then HClO4. The perchloric acid, it is the chloric acid. This perchloric acid is the strongest acid, and hypochlorous acid is the weakest acid. These are the oxyacids. Then we got the interhalogen compounds. Which is most important? Interhalogen compounds. Interhalogen compounds. The compounds formed, the compound formed by two different halogens, are called interhalogen compound. Interhalogen compound. That means say ताकत भितर आउ के हेलोजन जान फ्लोरीन क्लोरीन ब्रोमीन आउट हेलोजन ताकत भितर जो फॉर्मेशन हम जो कंपाउंड आग से इंटरहैलोजन कंपाउंड्स. ये टाइप्स ऑफ को एक्स टाइप, ये एक्स टाइप, ये गोटे हेलोजन, ये हेलोजन, डिफरेंट हेलोजेंस, टू डिफरेंट, वेयर एज A and X are two different halogens, The two different halogen X type X type, we may write CLF, BRF. A is Cl, X is F. So 1, 1. Therefore, it is called X type. Then it is called interhalogen compound. Similarly, AX3 type. AX3 type will be CLF3, BRF3, IF3 like this. AX5 type, AX5, what A man different AX5 type, we may write IF5, BRF5 like this, BRF5, CLF5, AX7 type, AX7 that mainly form IF7, most of the IF7 compound. Due to bigger size, they easily 7 plus 7 देखो In this case ClF, and this structure of this compound ClF3, BrF3, IF3 is T-shaped. It is T-shaped. Particular hybrid orbital, hybridization particular. It is T-shaped. A structure. The structure of X3 type like this: Cl, F, 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 like the T, like T. Here is a lone pair. Here is a lone pair, 2 lone pair, 3 bond pair. It contains 2 lone pair, 3 bond pair. And the type of hybridization is sp3d. sp3d out of 5, it from 3, 3 p, sp3 hybridization. In the IF5, it contains square pyramidal. It contains square pyramidal. 5टा पोजिशन रोचे बॉन्ड रोचे आ गोटे मझे लोन पेयर रही होची स्क्वायर we may write like this: structure shape is square pyramidal, but the hybridization is sp3d2, sp3d2 like this x5 type. I F one lone pair remain there. It is called one lone pair per bond pair. IF7 is pentagonal bipyramidal. Shape is pentagonal bipyramidal. Bipyramid. Pentagonal bipyramid. Pentagonal bipyramid like this. 5टा थिबो 1 2 3 4 5 ऊपर गोटे तळे गोटे. I F F F. It is lone pair नहीं, only sub bond pair F F. It is the IF7. It contains 7 bond pair, only 7 bond pair. So these are all about intelligent compounds. So these are the compound study of halogen family. Now we have to go to courses there. Preparation properties of chlorine gas. Preparation and properties of chlorine gas. Of chlorine gas, Cl2. It is prescribed in course only. Only amendment chlorine gas is there. Preparation properties of chlorine gas. Preparation. How chlorine can prepare? Preparation. In the laboratory preparation, when potassium permanganate is treated with concentrated HCl, we get chlorine gas. हम तो आयोनिकली में राइट द इक्वेशन हम आयोनिकली लिखि पारियो सुविधा रे आगुरी हम कहै छी केमिनोफोर केमिति करा जाय रिएक्शन दीटा बाटे करि परिबा केमिनोफोर treated with the concentrated HCl we get chlorine gas. We write like this आयोनिकली आ दीटा लिखिबा केमिनोफोर तो भांगी दबा हमें K2O partial equation method 2MnO plus 5O K2O plus sulfuric acid plus HCl. We are taking HCl here. HCl we get 2 HCl habo 2 KCl प्रति पार्ट बैलेंस हबो प्लस H2O MnO प्लस HCl MnCl2 plus H2O. Then again HCl last plus O, H2O plus chlorine, H2O plus chlorine. ताकू तापर मिसे दब नीचे ये 5O अच्छी ये 5 2MnO अच्छी ये 2 बैलेंस करने सुविधा ताले बर्तमान देख केमी हो 5O ये 5O कटिगला KMnO4 ये 2 KMnO4 कारण बैलेंस 2 KMnO4 plus look at here 2 4 6 10 16 HCl will get कटिगला सब K2 कटिगला 2 कटिगला 5 कटिगला सब कटिगला will get जहाँ आसो निजे मिसई दे पारिबो you can add all things similarly they will look at here 2 KCl plus 2 MnCl2 plus 5H2O 2H2O 1H2O 8H2O 8H2O plus 5Cl2. So this is the balanced equation by this method, but nowadays we are using ionic equation method. It is one method we can write ionic equation method. How to balance the equation by ionic equation? With simpler one, ionic equation we may write this MnO4 minus, here is MnO4 minus, manganese remain plus 7 state goes to Mn plus plus. Since it plus 7 to plus 2, we have to add 5 electron here. Balance kare apan 4 ta O achi, we add plus 8H plus. We get Mn plus 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 4H2O. And Cl minus form minus 2Cl minus minus 2E it form chlorine. Similar, it is a very easy method. Here 5A2 you add 5, multiply 5 you multiply 2 and cancel these electrons. We get 2MnO4 minus plus 10Cl minus plus 16H plus get 2Mn plus 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 5Cl2 plus 8H2O. This is the balanced equation for preparation of chlorine by potassium permanganate. This is a method of potassium permanganate we can do. Second method we can do direct. Second method. It is a laboratory method. Second method we prepare when manganese dioxide heated with HCl. Second method. When manganese dioxide treated with HCl, we get manganese dioxide जब HCl मिसेगा, we get 4 HCl कर दियो, MnCl2 plus 2H2O plus chlorine. We get also chlorine gas. Heat कर ले. Third point, we can also get when ozone treated with HCl, O3 form O2 plus O, 2 HCl plus O it form H2O plus chlorine. We cancel this. We get also chlorine preparation. So this is some of the preparation of chlorine. Then the most important property of chlorine is action with the ammonia and action with the alkali. Action with the ammonia and action with the alkali, which is very important. What happens when chlorine is treated with ammonia? What happens when, most time the question asks, what happens when chlorine is treated with ammonia? When chlorine treated with ammonia, first you write Cl2 plus ammonia, dita condition asibo. 3Cl2 plus 2NH3 N2 first step 6HCl प्रथम या लिखि दबो जब फर्स्ट रिएक्शन जोटा पर एक्सेस ऑफ एमोनिया ही पारे एक्सेस ऑफ एमोनिया और एक्सेस ऑफ क्लोरीन ना एक्सेस ऑफ एमोनिया हेले एमोनिया टा रिएक्ट विथ HCl एक्सेस ऑफ एमोनिया वी गेट एमोनिया प्लस HCl वी गेट ammonium chloride. So this multiply by 6. Cancel. Kalapare will get ammonia excess, ammonium chloride. 3 chlorine plus 8 NH3, we get N2 plus 6 NH4Cl. This is the when excess of ammonia. If excess of chlorine, these step likhe padta. But excess of ammonia, excess of chlorine. Excess of chlorine excess of chlorine will get similar manner 3Cl2 plus 2 NH3 will get N2 plus 6 HCl, then N2 plus Cl2, so chlorine like nitrogen ta. And nitrogen will react excess NCl3 NCl3 2 NCl3 तापर तो मिसाई दे पारिबो ताले N2 कटिगला we add this. So this is the excess of chlorine, this is excess of ammonia. Here we get nitrogen trichloride NCl3, here we get ammonium chloride. This is the difference between what happens when chlorine is treated with ammonia. You write down both. When excess of ammonia, it gives ammonium chloride. With excess of chlorine, we get nitrogen trichloride. Then excess of alkali. Alkali, excess not excess, khali alkali, exon with alkali. Exon with alkali. Sodium hydroxide. Sodium hydroxide से तो chlorine पक्का है उसमें. What happens when chlorine is treated with sodium hydroxide? Both cold and hot. Both cold and hot condition. हम बीटा reaction लिखा chlorine. What happens when chlorine is treated with sodium hydroxide? You write down chlorine plus HCl will get chlorine plus H2O. Chlorine plus H2O, you get first step HCl plus HOCl. NOH plus HCl will get NaCl plus H2O. Put again NOH react with NOH plus HOCl will get NaOCl plus water. So this is the reaction in cold condition. You may cancel this HCl, HCl, HOCl, HCl. You take this chlorine plus H2O, H2O potassium H2O जाउची, हम H2O मिसेबाने plus 2 NOH. We get 2 NOH, 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 2 NOH. We get NaCl plus NOCl plus 2 H2O, H2O plus H2O. Then sodium chloride by sodium oxychloride. Sodium oxy by hypochlorite, oxychloride or hypochlorite, NaCl plus water. Now, if in a hot condition, then these three steps, chlorine plus H2O remain HCl, HOCl, NOH plus HCl, NaCl plus H2O, NOH plus HOCl, NaOCl plus H2O. Again, another will be NaOCl, 3 NaOCl, it forms NaClO3 plus what step of the cabo 2 NaCl. We get sodium chlorate. तापर तम मिसेरी परिवर्तन. You add all these things. मिसेरी जासल देशी दो सेटी पाइला में sodium oxychloride, एटी पाइला में sodium chlorate. Sodium hypochlorite, here we get sodium chlorate. CHLORAT. Sodium chlorate. So this is the reaction alkali. Reaction of hydrogen, suppose. What happens when chlorine is treated with hydrogen? When chlorine is treated with chlorine with hydrogen, Cl2 plus hydrogen, it forms 2 HCl, like this. So these are some of the bleaching action due to the, you may write, chlorine plus H2O, 2HCl plus O. This oxygen is used as bleaching agent for chlorine. This is all about your chlorine. So we discussed the comparative study of group 17 elements. Oh, thank you for patient hearing.